Today we are going to discuss about the topic infrared or vibrational spectroscopy. It's a type of spectroscopic technique. As we studied UV visible spectroscopy, that is interaction of electromagnetic radiation in the range of 300 to 700, 800 nanometer range. That type of radiation is known as UV visible radiation. If a material, if a molecule interact with this radiation of 300 to 800 nanometer, there is change in its electronic energy levels. So then electronic energy is changing in the electronic energy levels, and that type of spectroscopic technique is known as UV visible spectroscopy. And if conjugated bonds are there, double bond, triple bond is there, there are different types of electronic transitions are there. Sigma to sigma star, pi to pi star, n to pi star, n to sigma star, different electronic transition are there. And application of UV visible spectroscopy. Here today we are going to take infrared spectroscopy, or it is otherwise known as vibrational spectroscopy. Why it is known as vibrational spectroscopy? If a material, if a molecule it interact with electromagnetic radiation in the range of 400 to 4000 centimeter raised to minus 1, that is wave number. If a electromagnetic radiation with a wave number 400 to 4000 centimeter raised to minus 1, then there is change in its vibrational energy levels. As we know, a molecule, the total energy level is the sum of its rotational, vibrational, electronic, and translational energy level. If a molecule interacts with the infrared radiation, then there is change in its vibrational energy levels. Based on that one, we can able to analyze the functional group, or we can able to analyze the nature of bond present in a molecule. Is one of the important application of this infrared spectroscopy. Can be able to analyze the functional groups like OH, NH2, HCl, CO2, or carbon-carbon stretching, carbon-hydrogen stretching, carbon-carbon bending, carbon-hydrogen bending, stretching and bending bonds present in a particular molecule. And that type of spectroscopic technique is known as infrared spectroscopy or vibrational spectroscopy. Nowadays, in modern technological field or modern material science field, we are widely using this infrared spectroscopy for the characterization or not to find the unknown functional groups present in a molecule. That is why application of this infrared spectroscopy. That is spectroscopic technique that deals with the infrared region of the electromagnetic spectrum. That is the wave number 400 to 4000 centimeter range to minus 1. Light with a longer wavelength and lower frequency than visible light, and that type of radiation is known as infrared radiation. And if a molecule interacts with the infrared radiation, then transition in its vibrational energy level. As we know, this is the energy level. That is different electronic energy levels are there. This one is the electronic energy level. Electronic energy levels containing different vibrational energy levels. Vibrational energy levels containing different rotational energy levels. That is, electronic energy levels are sum of vibrational and rotational energy levels. And also vibrational energy levels containing rotational energy levels. That is transition. That's why higher energy electronic transition is otherwise known as higher energy transition, and vibrational energy levels also containing rotational energy levels are there. That is the energy level diagram. Then which type of molecule shows IR active, or which type of molecule shows IR or vibrational spectroscopy? That's one of the important questions. If a molecule with a change in its dipole moment, if a dipole moment is changes upon vibration, and that type of molecule is IR active. So there's two examples are there. The first one is O2, N2, and H2 molecules are there, and another CO, HCl, H2O molecules are. This molecules is known as homodiatomic molecule. O2, N2, H2. Example for homodiatomic molecule. This is another CO, hydrodiatomic molecule. If this type of molecule or double bond or N double bond, N triple bond, N H H, that is O2 N2 H2. If a molecule like this in molecule must cause a change in the dipole moment of the molecule. Molecular vibration must cause a change in the moment of the molecule. So this O2N2 is a homodiatomic molecule. There is not a change in molecular vibration, does not occur a change in its dipole moment. So this type of molecules are IR inactive, or this type of molecule, homodiatomic molecule, does not shows infrared spectroscopy. But this CO, HCl and H2O molecule, CO is a heterodiatomic molecule, and if some vibrations are present in this molecule that changes its dipole moment, or due to some vibrations its dipole moment changes, then so that's why this type of molecules are infrared active, or this type of molecule shows infrared spectroscopy. That's one of the important selection rule. Another section is there, selection rule, but important criteria for a molecule shows infrared spectroscopy based on its change in dipole moment upon molecular vibration. Then next we this type of molecules are IR active. Then next is different modes. As we know, there are molecular vibrations which changes its dipole moment, and that type of molecule shows IR active. Then what are the different modes of vibrations present in a molecule? What are the different modes of vibration present in a molecule? There are two. The modes of vibration or molecular vibration present in a molecule is classified into two: stretching mode of vibration and bending mode of vibration. What do you mean by a stretching mode of vibration? If you, for example, if you take a two straight line, one end is A, another end is B. If it's if A to B is a bond length, if it is bond length is changes upon vibration. A to, if a straight line A, B, if bond length changes upon vibration, and that type of vibration is known as stretching mode of vibration. Another, if a ABC is a triangle is there, bottom portion B, C, and top portion A is there, and if its bond angle changes, bond angle is there, bond angle changes upon vibration, and that type of vibration is known as bending mode of vibration. That is the two mode of vibration: stretching mode of vibration and bending mode of vibration. And in stretching mode of vibration is further classified into two: symmetric stretching and asymmetric stretching. And bending mode of vibration is further classified into in-plane and out-of-plane bending vibrations. And in-plane bending mode of vibration is further classified into rocking and scissoring. Out-of-plane bending is further classified into wagging and twisting. As we know, what is different modes of vibration? If I want, it is the stretching mode of vibration. First is symmetrical stretching. As we know, here bond length changes symmetrically changes upon vibration, and that type of mode that this one is asymmetric. Here one elongates, another is one is moves away from the central atom, other is moves towards the but in a symmetrical both are simultaneously moves away from the central atom and come closer to the central atom. That is known as symmetrical. Here this one is moves away from the central atom, another come closer to the central atom. that is, or asymmetric. Then second one is bending vibration, scissoring, incline bending. It is bond angles. Bending means its bond angle changes upon vibration. Here, both is come. This one is 2n. Both n come closer to the come closer, then moves away from this end, and come closer and moves away, and that is scissoring. Then next is rocking. One is come moves come towards the center. Another one moves away from the center, and that type of vibration is known as rocking. This is out barging is one example for out of plane bending vibration. That is number. It is this one. Two is come closer to the both simultaneously come closer to the observer and moves away from the observer. That's why it is a out of plane modes of vibration. Here, here this one is the here testing. One is come closer to the observer, another one is moves away from the observer, and that type of vibration is known as out of plane vibration is distinct mode of vibration. And this one is classified further. We can symmetry represent the two modes of vibration. The stretching, two types: symmetric stretching, that is simultaneously the bond length changes. Asymmetric, one is changes and moves away from the central atom. Bond angle changes. One is come closer to the central. That is known as asymmetric mode of vibration. And bending to in plane and out of plane. In plane, rocking. There is one move away from the central atom. That is known as rocking, and say representation for rocking. And scissoring, both then come closer to the observer and moves away from the central atom. And weighting, this one come closer to the observer, that is represented as plus, and moves away from the simultaneous moves away from the observer, that is represented as minus. And distinct, and plus come closer to the observer, moves away from the observer. That is the different modes of vibration present in a molecule, and that is the basics of this higher spectroscopy.